Okay, in lesson 16a, we're going to be talking about how we describe rates. And in particular, we describe rates using slope when we're looking at things graphically. Anytime you hear the word rate, it's something per something. Miles per hour, miles per gallon, feet per second. There's all kinds of things what we express as rates. So we want to be able to express rates as slopes and calculate that slope within direct variation situations. Slopes have to have units to make them meaningful and to make us be able to apply them. It says interpreting numbers in advertising or product descriptions can be problematic. Data can be presented in ways that point to faulty conclusions. The table below shows the approximate distances that 3 vehicles can travel on a tank of gas. A Suburban can go 651.0 miles on a tank of gas. A Focus can go 446.4 miles per tank. And a Volt can go 380.0 miles per tank. It says write down one conclusion or impression that you can draw from the data in the table. Well, we can obviously draw the idea that if we have a full tank of gas and we're relying only on gasoline, we can travel the furthest with a Suburban. However, I believe that the Volt is an electric car. So you can travel quite a distance on that without actually using any gas at all. The other thing we don't really know is how large each gas tank is. Just because you can go farther on one tank of gas in a Suburban doesn't mean you're going to be getting a better gas mileage. It may have a very large tank, whereas a Focus is a much smaller car. It may have a very small tank. It says a Suburban has a fuel capacity of 31 gallons. How can you use this new information to find how far a Suburban can travel on 1 gallon of gas? So they're asking us to calculate the miles per gallon. So we know that one tank of gas, if we go back, let's see, goes 651 miles. So we can go 651.0 miles. And it is important that we have units on one tank of gas. Well, one tank is the same as 31 gallons. So now you need that calculator, 651 divided by 31. It comes out to be exactly 21 miles per gallon. That's a rate. Rates always have that word per in it, and rates are often graphically expressed as slopes. Let's keep going. It says calculate the distance that a Suburban can travel on 1 gallon of gas. Write your solution as a unit fraction with labels in both the numerator and denominator. So it was 21 miles on 1 gallon of gas. It says create a table like the one shown. Use your answer to question 4 to calculate the distance a Suburban can travel on the given gasoline amounts. Well, if we have 1 gallon of gas, that's supposed to be gallon, we will go 21 miles. If we have 2 gallons, what you would have to do is take this rate, 21 miles per gallon, and multiply it by 2 gallons, and you end up getting 42 miles. You can see each additional gallon gives us 21 additional miles. So 63, then 84, then 105, then 126, and 137. Whoops, I'm sorry, 147. Little typo there. Notice that every time the amount of gas increased by 1 gallon, the distance increased by a fixed amount. This fixed amount represents the slope in the relationship between gas consumption and distance. What is the fixed amount? This fixed amount from here to here was 21 every time. So if we think of each one of these changes as being 21 miles, you can see that each one of these changes was 1 gallon. One of the ways we usually write slope is that we say slope is the change in y over the change in x. That triangle means change. Well, the change in y each time was 21 miles. The change in x each time was 1 gallon. Or you can write that as 21 miles per gallon. It says plot the coordinates of the point that represent gas and distance for the Suburban. So 1 gallon of gas is 21 miles. 2 gallons of gas was 42. 3 was 63, and we're kind of having to estimate a little bit. 4, of course, was 84, so 84. 5 was, whoops, sorry about that, I got this a little straight. 5 was 121, I believe. No, sorry, 5 was 105. 6 times 21 was 126. Oh, sorry, I keep getting accident. So you see, all my marks didn't show up. Let's see, 3 was 84, so 50, 60, 70, 84. 4 was, I'm sorry, 4, let me fix that. Sorry about that. Was doing good, but they weren't all showing. Why does that not want to erase that point? Let's see. Eraser. Oh well, it didn't want to erase. That was 3 was 63. 4 was 84. 5, let's see, 6 was 126. 5 was 105. Bottom line is, if we graph these points, we're going to get a nice straight line. It's really hard on this tablet for me to show, but it's going to look something like that. They drew it much better. They didn't have any trouble graphing it. But you can see it's going up 20, every time we graph, it's going up 21 miles. It's going over 1 gallon of gas. All right, part B, comparing rates. Okay, that can be comparing the slopes, 2 different situations to make a determination. All right, in part A, given some additional information, you were able to convert what you knew about miles per tank into information about miles per gallon for the Suburban. We also created a graph. What do you think the graph of gas versus distance will look like for the Focus and for the Volt? Remember that the independent values on the horizontal axis are gallons, and the dependent values on the vertical axis are miles. So, just to give you a refresher, when you graph, you have two axes. The horizontal one is always the independent. We think of that as being the x-axis. The y one is the dependent. And remember, when we get that slope, it is the change in y over the change in x. All right, what information do you need so that you can check your prediction? Well, what I think the Suburban doesn't get very good mileage. I suspect that you'll be able to go more miles per gallon with the Focus and maybe even more miles per gallon with the Volt. So I think they're going to have some different slopes, okay? Let's see. A Ford Focus has a capacity of 12.4 gallons, while the capacity of a Chevy Volt is 9.3 gallons. Use this new information to calculate the slope for each linear relationship. So we'll need the mileage as well. So a Focus is 446.4. 446.4 miles per tank, but we know that that tank for that Focus is 12.4 gallons. So that's going to give us, when we do our division, 446.4 divided by 12.4, that is 36 miles per gallon. Remember the Suburban, this is the Focus. The Suburban was only 21. Now for the Volt can go 380. So 380 miles. It has a very small gas tank. It only holds 9.3 gallons. 380 divided by 9.3 is 40.9 miles per gallon. I did round that just a little bit. It's 40.86, so 40.9. So we can see we actually get the best mileage with the Volt. Oh, let's see, make sure I typed everything in. Was it 380? It was exactly 380 divided by 9.3. Okay. Just create tables of values for the Focus and for the Volt as you did for the Suburban. So if we, for the Focus, 446.4 divided by 12.4, remember this one came out to be 36 miles per gallon. This one was 21 miles per gallon. 380 divided by 9.3. This one was almost 41. If it had said to round it to the nearest, we could have said 41, but I put 40.9. Okay, what does that mean? Well, it means 1 gallon of gas will go 36 miles. Times 2, 36 times 3, or I can just say plus 36 plus 36. Each time we use 1 more gallon of gas, we travel 36 more miles. On the Volt, for the Volt, let's just go ahead and call this 41 just to make it a little easier to fill in our table. 41 miles on the first gallon, another 41 miles would be 82. Another 41 miles would be 123, 164, another 41 miles, 205, 246, 287. If we were to draw those additional ones, we would see the Focus went 36 miles on the first gallon. On the second gallon, it had already gone 72. So our line would start here, and I can't draw it really straight on this tablet, but keep going, something like this. The Volt would go 41 on the first gallon. By the second gallon, it could go 82. So it would be even steeper. You can see it would travel even farther. And again, this not real accurate, but this is our Volt. This is our Focus. This is a Suburban. How do the three slopes you found and the graph you created allow you to compare the fuel costs of operating the three cars in a meaningful way? Well, we can look at the graph and see if we only bought 1 gallon of gas, we could travel much further on the Volt. If we bought 10 gallons of gas, the Volt would go the farthest and the Focus and the Suburban. It allows us to really see what's going on. All right, part C is going to continue this discussion of slope, and it says we're going to understand the meaning of slope in problem situations. Any 2 points on a line can be used to find the slope, and we want to calculate slope from 2 data points in a linear relationship. It says the Smith family is thinking about changing cell phone carriers and possibly getting additional phones. After doing some research, they found a plan that includes talk, text, and 1,000 minutes that can be shared among the users of all the phones. It says, look at the first 2 data points in the table. What do they tell you about the slope of the relationship between the number of phones and the monthly cost? So we're only going to look at these 2 points. Data point 1, data point 2. We can think of this as being our X value, and this would be our Y. Remember, Y is dependent. The cost depends on the number of phones. You can look at that. The cost depends. Cost is dependent. We can see that when we add a phone, our cost goes up $10. So that's what I see. I see one additional phone costs $10 more. It says now refer to the second and third data point. So now we're looking at this point and this point. We can see here 3 additional points cost $30 more. 3 additional phones. Well, you know, that's really the same. 1 more phone costs $10 more. 3 more phones cost $30 more. So this is linear. Because if you think about it, each extra phone is costing us $10 more. It says plan how you would find the slope if you were using the first and third data points. You can describe your plan in words or set up a mathematical expression. Okay, remember this is X, this is Y. To get slope, we want to do a change in X. I'm sorry, I said that exactly backwards. Let's not make that mistake. We must do a change in Y divided by a change in X. And it doesn't matter which 2 points you use. A lot of times you see this written as Y2 minus Y1 over X2 minus X1, and you just pick any 2 points. They're asking us to use the first and third points. So we're going to use this point and this point. All right, look at Y. Y went from $99.99 to $139.99. You can think of this as beginning and final. So we're going to do the last one first, $139.99. 99 minus 99. That's the change in y. What was the change in x? It started at 2 and it ended up at 6. That's 6 minus 2. In other words, the cost increased by exactly 40 if you subtract, and the number of phones increased by exactly 4. Now we need labels on slopes. 40 divided by 4 gives me a slope of $10 per phone. So with this cell phone plan, each extra phone costs $10. Do you have enough information to predict the price if the Smith family decides to get 5 phones? I think we do. We know that the first phone, let's just make a table, was $99.99. If we add one more phone, wait, let's go back. Was the first phone? Whoops, no, I do not want to do that. We'll discard. I accidentally went back before I wanted to. Actually, the first 2 phones cost $99.99. So let's figure out what 5 phones would cost. We have the number of phones, and we have the cost. We know 2 phones is $99.99. We know 3 phones is $109.99. We know that that slope is $10 for 1 phone. So we just add 1 phone and we add $10. And we add 1 more phone and we can add all the way up to that 6. So they gave us this point and this point and this point, but we can figure out points in between by using our slope. So 5 phones would be $129.99. And that's the end of our lesson. I hope that helps you understand slope and rates.